So now that we've done square roots with numbers, we're going to do square roots with variables. Variables, x, y's, b's, a's, c's, all that stuff. If I take the square root of this, we're going to separate this as much as possible. Let's start with the 32. 32 is, let's see, I can think about that as 16 times 2, then I still have the b to the fourth. And what I want to think of is taking this square root of 16 as 4, leaving behind the 2 inside, and then the square root of b to the fourth. Well, what is the square root of b to the fourth? Let's kind of go over here off to the side. If I have the square root of b to the fourth, I'm going to take the exponent and divide it by 2. Because that's what really it comes down to. B to the fourth square rooted is actually b squared. So we're going to pull that out as a b squared. And then I end up with, let's see, just the 2 left in. So my final answer is actually 4b squared times the square root of 2. And that's helped me simplify this greatly. Let's kind of do it another way in number 2. If I take 63 and I do a prime factorization of 63, I end up with 9 times 7 or 3 times 3 times 7. Well, let's express that as negative square root. This would be 3 squared times 7 times a to the 8th times c to the 10th. And we're going to take everything with an exponent, divide it by 2 when we bring it out. So look at what happens. I still have the negative, because that's a negative 1. Square root of 3 squared is 3. Let's do the a to the 8th becomes a to the 4th. C to the 10th becomes c to the 5th. And, oops, still have a square root of 7 left. So that's a simplified answer, because I've taken as much out as possible. Number 3, let's see, 56. I can think about that as, let's do factorization, 8 times 7, 4 times 2 times 7, or 2 times 2 times 2 times 7, which would be 2 to the 3rd power times 7. So this becomes the square root of 2 to the 3rd times 7 times r to the 6th times s to the 5th. Okay. We're still going to divide exponents by 2. If I divide the 3 by a 2, what I get is basically 1 remainder 1. In other words, think about this as saying, well, it's really 2 squared times 2, and it's this 2 squared that's coming out as a 2 with a 2 left inside. So if I think about it that way, I can kind of expand this out and make this s to the 5th become s to the 4th times another s. And then all the even powers are coming out. 2 squared comes out as a 2, r to the 6th comes out as r cubed, s to the 4th comes out as s squared, and everything else stays inside. 2 times 7 right here is 14. And really I just have an s left over. This s right here is left over, and everything else came out. Let's go to number 4. Whenever possible, we always want to reduce fractions. So 256 over 400. Well, you know, I could square root 256 if I kind of know my square roots. 256 is 16 squared, and that's one of the ones I wanted you guys to know. Separate the square roots up, so we go plus or minus, not radical, sorry, that's a mistake, plus or minus 16 over 20 x to the 6th. And now I have a little easier time reducing. It's plus or minus 4 over 5 x to the 6th. Number 5, it makes sense to reduce here before square rooting, so let's treat this as an order of operations. Cancel the 5 and then 45, and I get 9. Cancel the m and the m cubed, and I get m squared. Cancel the n squared and the n to the 4th, and I get n squared. That's the same thing as the square root of 9m squared over n, square root of n squared, and I get 3m over n. Lastly, when you see pluses or minuses, you need to think factor. You must factor. So we're going to take this, got the square root of m minus 6 times m minus 6, which is the square root of m minus 6 squared, which I can then express as m minus 6. Now, I have been mostly correct here, but there is one little thing that we run into. We're going to deal with this mostly in Algebra 2, but I did want you to make aware of this. If I have the square root of a number squared, like m minus 6 squared, if that number happened to have been negative, and I square rooted it, I would end up with a positive, which means that the square root of m minus 6 squared has to be the absolute value of m minus 6, not just m minus 6. Also means that these are absolute valued. Anytime I have the square root of a square, it's actually equal to the absolute value of the number. So now we move on to the solves. The property of square roots of equal numbers says that if you have r and s, r squared is equal to s squared if and only if either they're equal to each other or r is equal to the opposite of s. Here's how this plays. Whenever you're the one writing a square root symbol in, so I have n squared is equal to 64, and I'm going to stick a square root symbol in. If you're the one sticking the square root symbol in, you must put plus or minus on the other side. And that should make sense. And I'll show you why for 2 reasons. We end up with n is equal to plus or minus 8. Here's why that makes sense. If I were to take that and plug it back in, I do get 8 or negative 8 as a solution. Or if I took the original problem and set it equal to 0, I could factor it into n minus 8 and n plus 8, and that would tell me that n is equal to plus or minus 8. So however you get it, you have plus or minus 8 as a solution. Number 8, first we want to isolate the m squared. So we're going to add 120 to both sides. Get 2m squared is equal to positive 120. Divide both sides by 2. M squared is equal to 60. And then we're going to take the plus or minus square root of both sides. So I'm going to stick the square root, plus or minus. And I get m is equal to plus or minus radical 60. We want to factor radical 60 to see if we can break down into any perfect square factors. Now really what you can come down to is say, well, I know radical 60 is 4 times 15, and the square root of 4 is 2. So we have plus or minus 2 radical 15. For number 9, add 64 to both sides. So you get 9c squared is equal to 64. Divide both sides by 9. C squared is equal to 64 over 9. And then take the plus or minus square root of both sides. C is equal to plus or minus radical 64 ninths, which is equal to plus or minus 8 over 3. I should do set notation on these. And let's do set notation here. Moving along, it says find both roots of the equation to the nearest tenth. Okay, so this means we're going to need calculator open. Well, if I take this and I add 0.42 to both sides, I have 0.42 is equal to 6n. Divide both sides by 6, you get n squared is equal to, and that would be 0.07. And we could do, well, we want to do plus or minus, n is equal to plus or minus a radical 0.07. I could kind of write that as plus or minus radical 7 over 100, which is plus or minus radical 7 over radical 100, or plus or minus radical 7 over 10. That's the simplified answer. However, I also can just go straight from here and say, well, it wants me to round, so I might as well just put the square root. So second x squared of 0.07, and it gives me 0.264. And it wants me to round to the nearest tenth, so we'll just say 0.3. So I'd say n is approximately plus or minus 0.3. For this one, we have stuff being squared, so squaring for binomials means foiling. A squared plus 6a plus 9. And this is a squared minus 6a plus 9 equals 256. Simplify the left, the 6a's go. A squared plus a squared is 2a squared. 9 plus 9 is 18 equals 256. If I subtract 8, well, let's divide both sides by 2. That seems to be easiest right now. Get a squared plus 9 is equal to 128. and now we can subtract 9. A squared is equal to 119, which means that A is equal to the plus or minus square root of 119. So if I want to go and plug that in, radical 119, get 10.9. Okay. Next set says solve, find each answer to the nearest tenth. So find the length of the side of a square whose area is 500 centimeters. Let's draw a square. I'm going to put 500 centimeters squared as the area, and we'll say let x equal the length of the side in centimeters, which means that x squared has to be equal to 500, which means that x is equal to the plus or minus square root of 500. So go to the calculator. Square root of 500 is approximately 22.4. X is approximately 22.4. I'm going to reject negative 22.4 because side lengths can't be negative, and then we're going to express the answer in a complete sentence. The length of the side is 22.4 centimeters. Lastly, it says find the length of the side of a square. So let's draw a square again. If its area is the same as the area of a triangle with an altitude of 24 centimeters and a base of 12 centimeters. Well, length of the side of the square, it wants a square, so we're going to do an S here. Let S equal length of side of square in centimeters. I know the area of the square is S squared, and it wants a triangle with an altitude of 24 and a base of 12. Area of a triangle. Everyone by now should know the area of a triangle, and I had a group last year that refused to use any sort of resource, including their friends or, for God's sakes, Google, to figure out what the area of a triangle is. But if I were to Google this, I would see the area of a triangle is 1/2 base times height. If I draw a triangle, it has an altitude of 24 centimeters and a base of 12. This is obviously not drawn to scale. Then I know the area of the triangle is 1/2 24 times 12, or 144. Now I'm going to set up the equation. It says the area is the same, so that means that S squared is equal to 144. And if S squared is equal to 144, S would be equal to 12. So the side length is 12 centimeters.